And I'm going to okay. I'm going to put it in the chat for the ones who join later. Okay, so welcome everyone. I'm going to share my screen. Okay, so this is Adrián Cano. I'm coordinator of the Energy Efficiency and Sustainability team at SES, the Valencia branch in Spain. This is the agenda for today. We are going to have like a first block of presentations, some technical sessions that will start with a brief methodology description of the D2 EPC project and scheme that is going to be explained by Stavros Kolsios, that is research associate in the Center for Research and Technology Hellas in Thessaloniki, Greece. We are going to have a second session by Paris Fokaides, that is associate professor and researcher at the Frederick University in Cyprus. And we are going to have two demonstrative cases of our platform. Firstly, the Smarthome study case in Thessaloniki, and secondly, the Frederick University Building in Cyprus. Okay. After these four presentations, we are going to ask you to fill some questions, to ask a brief questionnaire of 10 questions. This is going to be a real-time questionnaire. We are going to share a code, a QR, that will allow you all to join an online platform in order to answer these questions. After answering the questions, we are going to present the results of the questionnaire of what you replied to those questions. This presentation is going to be shared by Paulius Spudis, that works at Kaunas University of Technology. And at the end, we are going to have like a brief discussion and conclusions for the results and the event. So I give the floor to Stavros, please, if you want to share your presentation, and we can start with the first session.
Hello, Adrian. Thank you for the short introduction. Do you see my screen?
Yes, perfectly.
Oh, great. So, I would like also to welcome you to the D2 EPC training workshop. My name is Stavros Kolsios, and I am a research associate at the Information Technologies Institute in Center for Research and Technology Hellas. We are located in Greece. In the first session, we will see a general overview of our project and the tools that we have developed for energy performance certificates. D2 EPC stands for Next Generation Dynamic and Digital Energy Performance Certificates for Enhanced Quality and User Awareness. It is a Horizon 2020 project with a 3-year duration. We started at September of 2020 and we end this September in 3 months. Our consortium is comprised of 12 partners from 7 European countries. We are 3 research centers, Kaunas, CERT and Frederick, 5 SMEs, namely Senercon, Cleopa, Dimo, nZEB, Hypertech and Geosystems, 2 standardization bodies, UNE from Spain and Austrian Standards, 1 industrial company, SGS from Spain, and 1 energy association, the Austrian Energy. So the ecosystem of our tools is comprised of 11 main tools. We start with the BIM-based digital twin, where we collect all the static and dynamic information for our building under examination. Then the first thing that we would like to do is to assess the performance of our building. We have three tools for it. The asset rating, where we examine the envelope and technical systems. The operational rating, where we examine the building's operation, and the building performance module for additional indicators on the performance. Then we can recommend some changes that can be made or some alterations in the operation of the building, or alert the user for several aspects that can change. All of our data are verified in order to be credible, and additionally we can compare our building to the performance of similar buildings, as you will see later. Also, we can present the results from an aggregated point of view in a GIS environment, and of course we can access all of our tools through our web platform. But let's take each component one by one. Starting with a BIM-based digital twin, we leverage BIM documentation in order to take all the static information, all the descriptions about the building envelope and the technical systems. And we have a good basis and a pre-existing 3D model of our building. Then we can connect to the various deployed IoT devices on the building, either sensors or meters that can deliver energy-related information. Both the information from BIM and IoT are integrated in and related into the data model. And we are now in the place of adding computational capabilities in our model to result to our building's digital twin. Proceeding to the evaluation phase, we have the asset and the operational rating. The first rating scheme examines the installed infrastructure and the building envelope. We are based on the ISO 52000 series of standards. We use a quasi-steady-state monthly calculation model where we calculate the energy demand of our building, then the delivered energy, and finally the primary energy. And we compare it with the respective values of the reference building. For the definition of the reference building, we have adapted the national values for each country. In the case of the operational rating, we are not so lucky to have existing ISO standards, so we proposed our own methodology. We have a total number of 26 indicators, which evaluate the delivered energy, the primary energy, cost, CO2 emissions, and both schemes result to an energy class rating from A to G. Proceeding to the enhanced set of indicators, we have a module that can deliver the smart readiness indicator, which is aligned to the latest European regulations and calculation recommendations. A tool to calculate the life cycle assessment according to levels methodology. Also, we have the indoor environmental quality, which can monitor the thermal comfort, the visual comfort, and the indoor air quality, while the life cycle cost can evaluate the cost, the operational cost of our building throughout its lifetime. In the added value services suite, we have the road mapping tool for performance upgrade, where we propose renovation actions that the end user could make. This tool has the asset diagnosis functions, which examines the building envelope and technical systems in order to produce multiple strategic scenarios and result to the building renovation roadmap. The AI-driven performance forecast module performs a building operational conditions forecasting, pattern identification, and recommends energy efficiency and human comfort actions for the user. The tool for performance alerts and notifications is able to notify the end user about aspects related to energy efficiency, human comfort, indoor environmental personalization, daily operation, maintenance, and retrofitting. With the benchmarking tool, we are able to perform infrastructure and operational classification for several building categories and result to a percentile rating within specified groups per location or per building type, let's say. Extract insights from the certification results correlation and indicate paths for performance improvements. The energy performance verification and credibility tool performs data stream reliability checks, which are comprised of series of quality checks and an overall quality monitoring with a set of performance indicators. Also, it is able to perform status monitoring for the deployed sensors and meters, and it is equipped with an alerting mechanism for device malfunctions or poor data quality. Through our web platform, we offer a common user-friendly and interactive environment for assessing all of our tools. The end user is able to perform ad hoc execution of our services, and there is a dedicated environment for the building model initialization. So the end user is able to upload the existing BIM file of their building and set up all the deployed IoT devices. Also, these actions are also validated in order to ensure a correct and coherent building model. Finally, through our WebGIS tool, we are able to deliver regional EPC related statistics with charts and plots per region, give attribute and special query capabilities, and offer an endpoint for data dissemination using OGC services. Finally, we also support 3D visualization of BIM models within IFC4 format. So that was a brief description of all of our tools and the end of the first session. Thank you for your attention. So, Andrea, the floor is yours.
Thank you, Stavros, for your great presentation. So once the methodology is briefly explained, I give the floor to Paris Fokaides, that is going to present some policy recommendations to encourage the use of more value-added energy performance certifications. So Paris, the floor is yours. If you want to share your presentation, if not, I can share it too. You are muted, Paris.
I believe I can share my screen. I don't know if you see my screen right now.
Not yet.
Okay, I believe that you see my screen now, yes?
Yeah. Yes.
Okay, in this brief section of the workshop, we are just going to introduce some main aspects of our approach, of the D2PC approach. which may be explained or may be addressed to the policy implication of our project. Particularly, our solution, the tools that you are going to the tools that are going to be presented, aim to fulfill the 6 dimensions that are given in this slide, and actually to introduce and to establish the definition of dynamic EPCs. That is the operational EPC, which is aligned with the changes that we observe in the building due to the behavior of the users and other aspects. Of course, we aim to have a solution which will be fully compatible with the needs of the EPBD and the EPB standards for the energy assessment of buildings. So this implies the fact that we have considered all main aspects that are related to the European standards, and we have based our work mainly on this field. Of course, another approach of the EPC, which will be shown in detail in the following presentations, is the fact that the EPC is a fully, it's an approach which is based on an enriched set of indicators for different aspects of the energy performance of buildings. And of course, the fact that the EPC establishes and promotes the first tool for the operational rating of buildings across Europe. So there are those member states who have their own operational rating schemes. However, the EPC also provides at the same time a tool which can implement the operational rating on an automated basis and deliver the results for the operational rating just by integrating information from digital twins and smart sensors. Of course, another important aspect of the EPC is the integration of the SRI in the energy performance assessment as an integral component of this certification of the building. And of course, the fact that the EPC is based on a series of dynamic tools, digital platforms, and in general, tools that are considered to be state-of-the-art in the field of the energy design and assessment of buildings. Now, starting with the first aspect, the introduction of the dynamic EPC concept. As assessors, you may be aware of the fact that the assessment of the EPC of a building occurs once every 10 years, and usually it occurs at the design stage of the building. Now, the main idea of the EPC is that we aim to introduce those aspects and those parameters which will allow the regular and frequent assessment of the building. So the information that will be provided to our tool, to the EPC, and which will be related to digital twins, will allow for the regular assessment of the building. And this will also introduce another aspect in the equation of the EPC, that is the factor that will be introduced will be the actual performance of the user of the building. That is, if we have buildings which do not have the same tenants and which change regular tenants, it will allow for the documentation, observation, and information on the actual performance of the users. So with our approach, we do allow for the actual consideration of the user's performance in the building. The other stuff that is important to the EPC approach concerns the fact that the EPC is purely based on EU standards. So we have refrained using any other standards than the CEN series standards, and we have worked hard to further develop the understanding of the standards and to contribute to their further development. So the EPC allows for the establishment of the 52000 series standard in a tool that allows for EPC, something which is unique, as this is one of the first tools across Europe that allows for the actual exploitation of the content of the EU standards as requested by the EPBD as well. And we also feel that this shows the direction for future generation tools, the fact that they should be based on EN standards. The third aspect of the EPC is the fact that the EPC introduces a series of indicators for the assessment of different aspects of the building, and these indicators are both asset and operational indicators. So by now, the main indicators that we have in EPCs across Europe relate to the energy over the time and the area, that is kilowatt hours per square meter per year. And then we also consider the CO2 aspect, that is the greenhouse gases emissions of a building over a given time period. These indicators, though, are not representative for the entire performance of the building, and we do need to have other indicators which would make the actual performance of the building more representative. And this need was captured by the EPC, and this need we fulfill. We meet the expectation of introducing new indicators, an enriched set of indicators, over 80 indicators, which are delivered and developed and integrated and delivered by the EPC assessment. Now, what concerns the operational rating, one of the main aspects of the D2PC tools and solutions is the fact that we recognize the gaps that we have in the European standardization in the field of standards for the assessment of the operational rating of buildings. And based on this need, we have initiated as a project the drafting and development and delivery of a new standard for the operational rating of buildings. This is a major need, and especially for the operational rating of buildings, but it is also a policy need which was derived, delivered, and introduced by the EPC project. And in general, the policy message that we have from the EPC in this field is that there is a significant need for the development of new standards, especially in the field of dynamic and operational rating and assessment of buildings. Now, what concerns SRI? SRI is the next big thing in the assessment of buildings, the sustainability assessment of buildings in the EU member states. It was introduced in 2018, and we are making now big steps towards establishing the smartness assessment of buildings. The EPC recognizes this reality, and it brings closer the SRI with the EPC in the sense that we try with the EPC to exploit as many information as possible from the information which is required for the extraction of an EPC towards integrating this information in the SRI and delivering the smartness assessment of buildings. This is not an easy exercise in the sense that the fact that we are using digital tools and thus BIM introduces many restrictions in the information which is included in the BIM files concerning the automation and control services of a building. However, the solutions are worked out towards delivering in a smooth and coherent manner the SRI of buildings and bringing the SRI assessment closer to the EPC assessment. This is a clear message of the project, and this is something that we have also integrated in the tools and services that we propose and we offer with the EPC. Finally, the need for the exploitation of tools that are used for the Industry 4.0 era, tools that are used for the digital assessment of buildings, for the digitization in general of the practices that we use for the energy performance and other recommendations that we have for buildings. We have tried in the EPC to integrate as many as possible tools that are related to the digitization era towards bringing the EPC closer to the current practices of the engineering work in the field of assessing the building's performance. So these are the main messages that we wish to deliver from the EPC, and the tools and the services that we are demonstrating are actually fulfilling the needs for covering these gaps and introducing these new practices in the EPC assessment across Europe. Thank you.
Okay. Thank you very much, Paris, for your presentation. So I give the floor back to Stavros, that is going to present our first study case. It's going to show the D2EPC platform to you all. And Stavros, your side.
So, you see my screen?
Yes.
Okay, perfect. So, in the third session, we will see together the Smarthome pilot building. It is located here in Thessaloniki. A brief overview of the building in order to have in mind what we will going to examine with our platform in the next in this session. We have a building, the first smart near zero energy building in Greece. We have a total floor area of 320 square meters. Half of the building is used as residential and the other part is used as offices, while we have an unoccupied space for the electromechanical equipment. The building has been constructed with cutting-edge envelope insulation materials, 16 centimeters of mineral rock wool and also XPS. On the windows, we have triple glazing and double glazing windows. In terms of its technical systems, our pilot case is equipped with 2 heat pumps, one for the ground floor and one for the first floor. It has a solar thermal collector for domestic hot water, a building applied photovoltaic installation of roughly 10 kilowatts peak, a building integrated photovoltaic installation of 0.885 kilowatts peak, and a wind turbine of 1.75 kVA. Additionally, we have a battery storage system of 4.6 kilowatt hours. Let's proceed to our platform to examine our building. I insert with my credential as an assessor. Okay. In the digital twin, we can see the 3D model of our building and the measurements of the sensors. But before the digital twin, I would like to show you how we result the digital twin. We have a specified tab for inserting the BIM file. Here we can see some details of the file, and we can perform some actions like change its name, the coordinates, share it, or download it. Also, after having uploaded and validated the BIM file, we are in the stage of adding the sensors, set up and perform all the actions in order to ensure a good correlation with the BIM model. Let's say in this case we have a movement sensor that is located in the living room 26 and which is in the residential thermal zone. Some of the sensors can be already deployed in the BIM file, while we can also add several sensors after uploading the file. Now let's go again to the digital twin. We can navigate through the BIM file and click on the objects to see their properties. Like in this case, we have a wall of 11 square meters and an orientation in the south, a tilt of 90 meters, etc. Navigate through the various sensors. Let's say here we have a multi-sensor which measures humidity, lighting, movement and temperature. These values are up to date. We had the last update about half an hour ago, and as you can see, the temperature right now in the house is 27 Celsius degrees, and we can zoom in or perform whatever we want. We can see it in a time scale of day, week, month, or even year. And this is the place where we can see all the information of our building. Then we will rate our building. Through our first rating scheme, the asset rating, where we examine the infrastructure and envelope of our building, we can see that we have an energy class A as a result. Here we can also see the results from the various energy stages, let's say, the energy demand, the final energy, and the primary energy. As you can see, there are a lot of negative values because we have an energy production from renewable energy sources. All the results are also presented per service and in total values or values per square meter. We can zoom in to the examined area, we can restore it, and we can download as an image or see the results in the data view. All the values here are monthly. For the annual sums of these values, we have a separate area in the bottom of the screen where we can see the sums, the annual sums per service or per energy carrier. In this case, the energy carrier, as we have heat maps, it is only electricity, and we have a surplus of energy production from the photovoltaics and on the building. So this is why you see negative values. And also the CO2 emissions and the cost. I remind you that all these values that we see in this screen are calculated values. Now let's go and see the measured values. We retrieve the values from the database and perform the calculation. In this case, our building has an energy class C rating. Again, we can see the results disaggregated per energy service for heating, cooling, and all the other stuff, electrical appliances and lighting in the same measurement, or disaggregated per energy carrier. 3/4 of our total energy, of the actual energy consumption, are derived from the electricity grid, while 1/4 from the PV installation on the roof. We can see in this case as well the monthly values. The values are disaggregated also in this case per service. We have the final energy, which is also the measured energy, the primary energy, which is the calculated primary energy with a primary energy factor, and the cost. All the values are also normalized per area, the square meters of the house, the volume of the house, the number of occupants, or the number of occupancy hours. As you can see, we have a flow from annual to month, and also we can see the daily variation of the energy consumption. In this heat map, we can see how we consume energy throughout the years and which are the most energy intense, let's say, days within the year. The third evaluation tool is the building performance module, as I said in the first session. Here we have 4 tools: the SRI, LCA, human comfort, and cost and economic. In the SRI, we can see a pre-filled form for the SRI calculation for the sake of time. As we can see, we have uploaded all the relevant information for the SRI calculation per domain, and within each domain are all the services related to our building. Having inserted all the values, we are able to complete the form and calculate the results. Let's see the class. It is a class E. And here you can see the analysis of the results per impact score for the 7 domains and per domain and per impact. Also, the values that in the bottom we have values with the 7 domains and the impacts. The aggregated scores and the key functionalities are also presented on the bottom of the screen, and that's pretty much all for the SRI. For the LCA, we have uploaded either from the BIM file or through our platform the APDs for all the materials installed on our building, and we are able to calculate the LCA score. As you can see, we have the table of the impact stages according to the levels scheme and the impact structural groups for Windows. In the tab for the human comfort and well-being indicators, we can see all the indicators related to how the humans interact within our building. Each indicator can be calculated for the separate deployed sensors. In this case, we examine the living room for a time range of the last 6 months. We can see the values for the thermal comfort, the air quality throughout the 6 months, and the visual comfort in the space. Finally, we can see and calculate how which is the economic performance of our building. We have only electricity, and if we assume a standard rate of electricity price at 25 cents per kilowatt hour, this can change per month, but we can assume it for this exercise. We can calculate and see which is the, okay, it's calculating the, not the energy gap, the difference, but it is like the energy gap, difference of the designed costs from the asset rating evaluation and the as operated cost throughout the year. We offer several views. We can see the monthly cost per carrier. In this case, it is only the electricity, so we have only one bar type. The monthly use, the monthly cost per use for all the services, and the total cost per month for all the services, both in kilowatt hours and in kilowatt hours per in euros per square meter. I'm sorry. And also we can have a prediction of the cost throughout the future years, the near future. Okay, so after having a good and thorough view of our building from the asset, the operational, and the building performance modules, we can now generate some recommendations about some actions that we can make on the building to increase its energy performance. As you can see here, we are at the present state, and with this timeline, we suggest to the end user to perform one renovation actions, and what will be the impact of these renovation actions. In this case, we have a pretty efficient building, so we hadn't much to propose. But you can see a good overview of our tool. And with this tool, I would like to conclude and end the third session. And Adrian, if you are okay with it, we can proceed to the fourth session and the presentation of the FRC pilot building.
Of course, Stavros, go ahead. Thank you very much.
Okay, thank you. Great. So, the Frederick University's new wing building is a building constructed in 2017, located in Nicosia, in Cyprus. It is a two-story building with a total floor area of 2,100 meters. It has a basement, a ground floor where it is mostly occupied by the cafeteria. The first floor is comprised of 3 seminar rooms, while on the second floor there are the offices. Regarding the building's envelope, we will have a glimpse of the elements that comprise the roof, the floor, the external walls, and the fenestration. We have external walls from concrete and 5 centimeters of insulation, while the internal walls are only comprised of 10 centimeters of bricks. The roof is a concrete and reinforced concrete slab with bitumen membrane for water insulation, and the floor is comprised of reinforced concrete and light concrete with some marbles on top. Regarding the fenestration, we have double glazing with an average U value of 2.8, and we have 3 main framework types: horizontal sliding from aluminum, pop-up windows from plastic, and sealed windows from wood. The heating and cooling system is comprised of 5 VRVs. We have a total heating capacity of 37.5 kilowatts and the total cooling capacity of 33.5 kilowatts. 4 terminal units are used 4-way cassettes, and on the right you can see the deployment of these units. The lighting system has a total installed capacity of 7.7 kilowatts and is comprised of square LED panels of 60 by 60 and spotlight lighting units. Now let's examine it through our platform. Again, we go to the digital twin tab and select the Frederick University. I hear some sounds. Okay. In the same manner as previously, we can have a 3D view of our building with all of its elements represented on the 3D model and the attributes on the left side, on the right side. While here we can see the measurements in the building. Maybe it is in the weak view. I can. There are too many sensors. Maybe. Okay. Okay, here we can see the energy meter in the ground floor in the yearly variation. So, having again all the information uploaded on the BIM-based digital twin, we can perform the asset rating on this building. In this case, we have a Class C building with the calculated monthly values for energy demand, final energy, and primary energy. The values are per service in total or per square meter. And on the bottom, you can see the annual values, respectively. For the operational rating, we see that we have a higher class, Class B, and on your right you can see the disaggregated energy value, measured energy values per service, 25% for cooling, 10% for heating, and the rest for electrical appliances and lighting. And here our only energy carrier is the electricity from the utilities, from the grid. Proceeding to the monthly values, we have the primary, the final energy, and the cost calculation in absolute values, in values per area, per volume, per occupant, and per occupancy hour, while in the daily variation of the energy consumption, we can detect a slight lower consumption at the Saturday and Sunday days of the week. And that's pretty much all for the operational rating. Proceeding to the building performance module, in the same manner as previously, we have pre-uploaded all the values for the building, and for each domain, if it is present or not, which are the services that are applicable, and which is the functionality level for each service. And after having all of them completed, we can calculate the SRI score of HRC. In this case, the calculated class is F, and we can see the results per impact score and per domain, and the analysis of the results in tables at the bottom of this tab. The LCA is also calculated like previously, with all the materials for its element type, and let's say for external walls we have the concrete, the gypsum wallboard, and the air barrier, the insulation. After having completed the form, we can calculate the results and see the results per impact criteria and the various impact stages and impact structural groups. In terms of human comfort, for the space of canteen, we have no measurements for thermal comfort. Neither for the rest. Maybe some another space have it. Maybe the last year. Okay, we have 0.53 thousand hours deviation. We can see the humindex levels, the air quality indicators, and no measurement for air quality and visual comfort. In any case, the results are presented in a form like previously. For cost and economic indicators, we have only electricity, like in the previous case, as we have heat pumps. Here we can assume a steady price of 35 cents per kilowatt hour, and with this assumption we can calculate the results. The monthly, and on the bottom we can see the variation for the designed and operated costs. As we can see, in the design phase we have a high operational cost on the first months, while this is not the case for the actual operation. And because we have inserted zero values in the inflation rate and discount rate, we see a steady predicted cost variation throughout the near future. One extra tool that we can present is the WebGIS. Here we have all the results per country or per region. The used values are synthetic because there is no existing database for all that aggregates all the EPCs throughout Europe. Here we can see our pilot cases. Okay, so our location is here. In the northern Greece, we have 9% of classes of buildings with A class, 30% with B class, etc. We can compare this region with the region next to each other. Similarly, we can compare countries. The EPC statistics through Italy and Greece. Okay. So as you can see, Italy is outperforming us in Class A, but we have a fair amount of buildings in Class B. But again, all this data are synthetic. There is some download links or feedbacks that you can send to us, and that's pretty much all. Also for the fourth session.
Okay, Stavros. So
okay.
Thank you very much for both presentations. So just before answering the online questionnaire, if anybody can raise a question or has a comment regarding the presentations, is the moment. We have like a few minutes just in case someone has some questions to Paris or Stavros. So open your mics and you can raise the question. So, okay, seems that we don't have any questions. If we have any, please let me know and we can answer it. So I'm going to share my screen again. Please, I kindly ask you to either read the QR or maybe you can access this web page and enter this code. We have a question, sorry.
On the chat.
Okay, on the chat. So it's a question. Do you consider measuring uncertainty of sensors and uncertainty in the input parameters to the calculations? Maybe Stavros, this is for you.
Yes, we have a specified tool, as I presented in the first session, the energy performance verification and credibility. This tool performs various checks in terms of the quality of the metering that we receive from our sensors, and in order to minimize the possible errors that we may have.
Have another question?
Why such a big difference between asset rating and operational rating in those buildings?
The difference is because in the case of the asset rating,
Stavros, sorry to interrupt. Adrian, if possible, please leave the QR code in the screen, so that people can scan and reply to the questionnaire.
No problem, no problem. I can let the QR while we discuss this.
Great.
So Stavros, sorry, difference between the asset rating and operational rating in the cases we presented.
Yeah, this is the most common question. In the case of the asset rating, we have a predefined set of climatic conditions, of indoor conditions, operating schedules that are applied for the building in order to examine the building under some standard operational conditions. Our target in the asset rating is not to predict the energy consumption of the building, is to examine its performance under predefined conditions. In the case of the operational rating, we take into consideration all the previously under real conditions, real weather conditions, real variable time schedules, the preference of the occupants. So all the above can generate a significant energy gap, as you can see. And this is something that highlights the significance of the operational rating and our attempt for the new standard along with Dr. Fokaidis.
Okay, thank you, Stavros. We have another question from David. You have modeled primary energy and measured final energy in the same dashboard, which are very different metrics. Will you target user groups understand this difference, and have they indicated that they need both values, modeled primary and measured final energy?
And there are some comments from Nicholas related to the previous question.
Maybe we can answer David's question and then we come back to Nicholas. So you have the question in the chat, Stavros, just in case you want to read it slowly.
Yeah. If you notice in the beginning of the session, I logged in the platform as an assessor. What you have seen today is not intended for the end users. To the end user is delivered only the energy class. All these results are targeted to people with technical expertise that can serve as assessors.
Okay, thank you, Stavros. Coming back from Nicolas' question, he said, but the limit of the classes are the same in case of asset and operational rating, right? Does that make sense?
Not actually. In the case of the asset rating, we compare the building with a reference building, which is a building that has the same character, not the same boundaries, the same geometry, but the values for its technical systems and building envelope, which are according the national legislation per country. In the case of the operational rating, we have a set of limit values, energy values, boundary values, let's say, per class. So even though the delivered class in the end is the same, A to G, the boundaries of each class are not the same.
Thank you. We have put the link for the questionnaire also in the chat, just to make it easier for you. Is anybody going to ask anything else? Okay, we have another question. Don't we need ways to achieve more comparability of results across Europe?
Of course, even though I think this is not within the scope of this project, it is an attempt to achieve more compatibility of results across Europe, but up to a limit. Paris, I don't know if you would like to mention something on this.
Well, yes, actually, this question is not within the scope of this project. This project aims to deliver a new approach for EPCs, which integrates many elements, many innovative elements. And it's also an innovation action which delivers these solutions to asset demonstrator to an operational environment. We do discuss about the developments in the field in the next 5-10 years, but for sure, we do not cover all aspects in the field of policy as well related to EPCs.
We have another question from Kurt. Okay, go ahead.
Hello, everybody. This is Kurt from Austria. I have a question. Did I get it right that you think a person should have a BIM model, the certificate calculation, and a bunch of time series data that is uploaded to this system? And then you can calculate your figures.
No, you didn't get it correct, Kurt. DPPC is a BIM-based assessment scheme. That is all you need to have is your BIM file. And we recognize the significance of BIM design for the future for Industry 4.0 practices. So our tool, you can just introduce your BIM file with all the required information, and the assessment is performed automatically. Also, what concerns digital twin, should a building be equipped with smart sensors and with power meters, we can actually, with less effort, do the operational assessment of the building on a real time. But certainly, the purpose of our tool is to implement the EPC. So our tool calculates the EPC. So at the end of the day, to answer your question, the prerequisite for the use of, the only prerequisite for the use of the EPC platform is a BIM file, only that. The rest is done by us.
Okay, but then I have another question. You have these measures from the sensors. These measures are provided by an algorithm or by a real sensor?
So it's by a real sensor actually, and it's a prerequisite to do the operational rating to have measurements. Now,
Okay,
if the measurements are available, we can do our work. If not, then we will not. But
okay,
in any
so
case,
I
we do
have
not.
to upload them. Is that right? If I would like to use this tool, I have to upload the sensor data.
Yes and no. So, Stavro, you can answer this one. Yes.
Yeah.
Maybe.
Okay, let me answer, and then there are two ways. You can either upload the measurements in a CSV file format, or you can set up your IoT equipment to send automatically the measurements to our platform in order to store the values and perform the calculations.
Okay, I see. And how long do you store this data? Or which time range is necessary? A year? A minute?
We are able to accept various time ranges, but we are not able to deliver all the result. Let's say if you give me measurements per month, I can't give you KPIs per day.
That's absolutely
Okay, but I can give you KPIs per year. Okay, and KPIs per month, of course. According to the resolution of what you give me, this will also result to the resolution of the KPIs that I give back to you. In any case, we need to have correct the total annual values of the energy measurements in order to provide the energy class. Without it, without the total consumption throughout the year from all the services, I am not able to provide the resulted energy class for the building.
Yeah. I totally understand. I think I totally understand. Another question is, I uploaded this for one building, and afterwards, if I have all my ratings, you delete everything I uploaded. So at the end, you only keep the results, or do you not keep the results?
That's a pretty technical question.
Yes and no, because that's a very sensitive personal data. If you are uploading who is when, where, how much people, you all mix that together to do your calculation, what I think is great. But I'm just thinking, what is the result or the effect on personal data I upload? Who have it? Who can access it? What's with that data?
Yeah, this is a very good point, and actually GDPR is one of the things that we are also working on, and digital security and all the related stuff. And I'm sure that when we will proceed to TRL9 with our solution, these topics will be covered. We have to face and understand that each product, each service is delivered and demonstrated at a specific readiness level. What we are seeing, this is a result of an innovation action, and we are actually demonstrating under operational environment the tool. When we will proceed to the stage of commercialization of the tool, topics like digital security, GDPR and in general of respecting the privacy issues will be managed in the appropriate manner.
Mm-hmm. And a final question, if you allow, is it possible to access one or the two examples that you showed today? So can everybody link in and examine the data?
I'm not sure. This is something that I have to discuss with the rest of my team to answer.
Okay, thanks a lot.
Okay, I think Thanos had his hand raised, maybe.
I have raised my hand earlier just to provide some context. I don't know because the conversation has moved on. The first thing I wanted to mention is that regarding the first question that was written in the chat, due to the uncertainty of measures and sensors, etc. I wanted to add that there are two layers of quality checks within the EPC. The first one concerns mathematical concerns the application of mathematical algorithms to perform cleansing on the initial datasets and outlier detection and imputation of values. And there is a second level of checks that guarantee that the values that actually obtained from the pilot buildings and then are utilized for the calculations of the KPIs of the project, for example, are also filtered in order to be credible and make reason. And in regards to the security that was mentioned previously, I wanted to mention that all data are transferred in an anonymized way. We do not maintain any addresses or names. They are all codified in order to adhere to the GDPR and all other security security obligations from the EU, and to be aligned with them. That was from my side. Thank you, and sorry for the delayed response to some of the questions.
No problem, Thanos. No problem. Sorry from my side. Thank you for your contribution. Okay, we have another question from Nicholas. What's your long-term objective? Do you want to commercialize this tool? Maybe Paris have commented about this, but if you want to double.
Sorry, can we repeat the question,
Yeah,
Adrian?
the question is, what's your long-term objective? Do you want to commercialize this tool?
I think Seth can reply to that. All research projects have explainable results, which ideally should reach the market. So this tool now it's demonstrated at an operational stage, and if everything goes well, there are the consortium agreement provisions and the exploitable results that we wish to demonstrate, and I'm sure that at some point the EPC will reach the market as well.
Thank you so much. Any other question, or we can move to the results? So, okay, maybe Paulius, if you have the real-time answers, you can share your screen, please, and we can see the results.
Yes, I have it. I see that most of the participants finished the answering, so I'm sharing the screen with the results.
Okay, maybe we can wait a couple more minutes. So, yeah, we can see your screen.
Great. So should we wait a few minutes, or we can proceed with the results?
So I don't know if you want to share, or I don't know if presenters have particular comments for every question, or do you want to see them all and then we can comment it at the end? I give the floor to you.
I guess we can move through each of the questions quickly and then maybe general. So for the first question, how the participants rate the information provided in improved EPC, we can see that evaluation is more or less positive. We have some opinions that maybe something could be improved in consistency and the clarity of the information provided, but more or less I can see that the result is very, very positive. Moving to the next question regarding the operational assessment. Again, we can see that there's a bit of division in the results in the answers, but again, the evaluation is quite very positive. We have just a few negatives, let's say, evaluations, which is partially disagree regarding comprehensiveness and comprehensiveness of operational features. For the third question regarding the integration of additional parameters such as financial, environmental, or human comfort, again, we can see that this is evaluated positive from the answers and more or less very positive. For BIM integration, we can see that the results is quite divided, but it's evaluated without with a neutral, let's say, opinion, or with a positive impact for BIM integration into EPC assessment procedures. For the SRI integration into EPC assessment procedures, we can see more divided results, but again, more or less it's evaluated positive. Most of the respondents fully agree that that will improve EPC accuracy. Also, we have some partial disagreements regarding these improvements. So maybe we can discuss this later if there will be some questions regarding this. For the added value of DTPC extensions, again, we get the positive feedback from the assessors. Most of them fully agree or agree to that this extension will have added value. Regarding energy efficiency improvements and interactivity of the tool, results quite similar as previous. The evaluation is positive or very positive to this, let's say, enhancement of EPC procedures. Regarding the motivation to undertake retrofitting measures, opinion is more or less neutral or positive regarding this. So we can assume that new generation EPCs will motivate building owners to undertake these measures. And for the role of EPC assessor, while issuing the EPC certificate through this platform, is more or less clear to the attendants, but also we can see that I believe some points could be a little bit more clarified for the assessment procedures. And for the final question regarding the DTPC solution influence to policymakers, we can see again that we have a positive, we aiming to have a positive impact on this. Most of the respondents highly believe that this tool and implementation of this solution will influence the policymakers to adapt these renovation policies. So in overall, in my opinion, you can see that the tool was quite well evaluated, but maybe some questions will arise from this, or some comments from other colleagues.
Thank you, Paulius. I don't know if any of the presenters have a comment at this respect. If not, I would like to raise a question or a suggestion, because firstly, thank you very much for providing your feedback. Is very valuable for the valuable for the project. Okay, so I've seen that 16% of the replies mentioned that the results of the D2EPC platform are not concise, are not so clear, and 11% of the replies think that the calculations of the D2EPC tool are not comprehensive. So I may ask for this attendance that think that maybe the results are not concise, if they can explain in which way they, I don't know, they don't see why are like this, or maybe no, I don't know, what do they suggest in order to improve the user friendliness or the presentation of the results. So we have a comment from Nicholas. From my personal point of view, you did a very impressive demonstration of the technical capabilities, but a poor demonstration of the meaning of the indicators you presented. Okay. So yeah, your recommendation in this case is to extend the meaning of the indicator. Maybe you don't know, if you didn't come to our previous workshop. We are developing also a technical manual for EPC assessors, in which everything is explained. Every indicator or every issue of the platform is explained, and yeah, it's a really necessary complement to the use of the platform. But your feedback is well noted. So any additional comment? Any feedback? Yeah, Panayota, please.
Yes, hi everyone. This is Panayota from CERT team. I'm part of the coordination team. Thank you all for joining us today, and it was a pleasure to watch this interaction with the participants. Some final comments from my side concerning the further steps, the next steps, and what we expect to have after this project that is actually ending on soon, this August. We, as a research center, we usually have within our aims to capitalize on the results of previous projects and work in other research projects and extend what has been applied and investigated. In fact, there are other projects of Horizon Europe that are relevant to the work that has been implemented in Discord EPC, and is using as basis some of our results. Further to that, we are building an exploitation plan with focusing on the exploitable results of our project and the digital platform that you have seen here. And we want to further develop this platform and be applied in a TRL level close to market if we find more funding opportunities. And all of this will be aligned, of course, with the consortium agreement. The part also, the main achievement of the project relevant to standardization that has been mentioned is the development of the standard for the operational rating, and this work is also being further developed as part of next projects that partners here are participating. So we are mainly intend to extend our work and further capitalize on our possibilities here, not just after the end of the project have the results forgotten. There is also the option for some of you, if you want to experiment with the platform, to try to register in the platform, and we can share with you a registration link and provide you with a test case, not for the use cases that you've seen here, but a test case file with a BIM file for a case building, so you can navigate through the platform and check the services that we provide. This can be included in the email that you will receive afterwards, after this workshop, with the questionnaires that we will share with you. We will want to give you more time to view the platform and take your time to answer more questions and provide more feedback for our services. This is all from my side. Thank you for participating, and hope to see you all in other opportunities.
Thank you for your contribution, Panayota. We have like a last question from David, and he said that the strength of this of the tool is the breadth of the data in one place, and the interface looks great, but the challenge is how does such a quantity of information help decisions in processes that require standard EPCs anyway, and who is going to use this extra information, and how is going to use this extra information? Maybe Stavros.
May I comment on this? As I said previously, what I have presented today is our platform from the assessor's point of view. Of course, we will present part of the information according to its stakeholder. The possible stakeholders can be the building owners or the building tenants, where they can see only the end results, and we would like to move away the idea that an EPC is only a static piece of paper that says an energy rating and nothing more, and it can be something more interactive. It can be like an application that you have installed on your phone, and you receive periodic notifications once per year for the operational rating, or even more frequent, in order to take actions that can increase the energy performance of your building and minimize your energy consumption, or increase the indoor conditions within your building. This is one of its main strengths. If we go to a higher level, for addressing public bodies or legislation organisms, then tools like the GIS and or tools with a more aggregated view on the EPC results can help them figure out better strategies in order to decarbonize the building stock in each area and promote measures that will actually have an effect on the living of the occupants and the energy consumption overall. According to the type of stakeholder that logs into our platform, it can have access to a predefined set of information. Not everything is for anybody. I think I have covered this question.
Yeah.
Hopefully.
Yeah, I think so. Thank you, Stavros, again. So, okay, it seems that we don't have further questions. So thank you all for joining the event, for your feedback. We really appreciate it. In the following days, you are going to receive like a more extended questionnaire with a few more questions in order just to have an added feedback from your side. Let's see the number of replies, but we kindly ask you, please, if you can help the project to answer as many questions as you can. So I'm going to stop the recording, and this is the end.